We are going to explain the atomic radius in this video. So, an atom has physical properties. These physical properties are important for multiple reasons, such as characteristics. Like, why do you identify an atom? We identify them by the physical properties. There are four main types of physical properties of an atom: electronegativity, atomic radius, ionic radius, and electron affinity. Now let's begin with the most basic one, which is electron. Now we're gonna begin with atomic radius. Now, atomic radius is basically the size of an atom and can be described simply as the distance of the nucleus to the outermost valence electron. The distance between the nucleus and the outermost valence electron symbolizes the atomic radius and the size of an atom. Here's the thing. As we go across the periodic table, the atomic radius of an atom will actually begin to decrease or stay the same. Because you see, atomic radius size increases as more electrons are added and more energy levels are added to the atom. But as we go across the group, limited amount of energy levels are added. But as we go down the group, more energy levels are added to the electron, which increases its size. Now, as more energy levels are added to the atom, its size will increase, but its effective nuclear charge will also decrease. Unlike across a period. And this follows to our next thing, which is the second atomic characteristic, and it's called ionic radius. Now, what is the ionic radius? I don't know. I'll tell you now. So basically, the ionic radius is the amount of energy required to donate an electron. And if you're seeing me here, I'm just getting this book. Why am I getting this book? So I can read off it, of course. So, we know that positive ions are formed as an atom loses electrons. So they become smaller than the original size. This is the loss of electrons. But negative ions are larger than their parent atom. What do you mean by negative ions? You mean ions that have gained electrons. As an atom gets ionized and gains an electron, its atomic radius will increase as more electrons are added to the structure, increasing energy levels. The higher the nuclear charge, the smaller the radius becomes, because the increase of attraction between outer electrons and nucleus causes the radius to decrease. Basically, ionization energy is basically the measure of the amount of energy required for an electron to be pulled to an atom. Here's an atom, here's an electron. High ionization energy to the electron. Low ionization energy here. Still attracts, but weak attraction. So what are the characteristics? Well, across the group, across a period of the periodic table, ionization energy will actually begin to increase. Why? Because, well, first of all, as we go across a period, ionization energy gets stronger, and distance from the outer electron to the nucleus will stay the same. Here's the thing. Ionization energy is determined by the distance of the first electron to the nucleus. The shorter the distance, the higher the effective nuclear charge, and the more likely that the nucleus will be able to pull the goddamn electron. Now, I'm saying this in a more sarcastic way. I'm acting it in a physical way, like a fisherman will do in Clash Royale. But, my God, what am I even saying? At this point, what am I even saying? This is all for me, of course, because who else watches these videos except maybe my school? And if you were watching this, I'm proud. So, down a group, ionization energy will decrease. Why it will decrease? Because more energy levels are added. As we previously said, down a group, more energy levels are added. This decreases the effective nuclear charge, as there are now barriers which prevent and reduce the ability of an atom or the nucleus to pull an electron. See this stuff, how we have a magnet. Let's just say this hand is a magnet. This is a metal. The magnet will attract the metal. But if you put a barrier between the magnet and the metal, it will decrease its power. Put another barrier, decrease its power. This is basically what happens when the nucleus tries to attract an electron and there are more energy levels added to it. Its attraction will be weaker and thus reducing its ability. So as you go down, ionization energy decreases. As you go across, ionization energy increases. But then what about electronegativity? What is electronegativity? Electronegativity is basically an atom's likelihood of snatching an electron. When we say snatching an electron, we literally mean snatching an electron. So, it is the ability of an atom to attract a shared pair of electrons in a covalent bond. Basically, what are the chances that this atom will be able to attract this electron from this bond? It's pretty likely. In a covalent bond, the atoms do not attract electron pairs in the bond. So basically, here's the thing about covalent bonds. They don't really attract electrons, they just pull them. They don't really take electrons, just, get them. I may be incorrect, but who cares? Yeah. So, electronegativity increases across a period as there are less energy levels to block the electronegativity, but decreases down a group because there are more energy levels which block the nuclear's ability to attract electrons. Blah, blah, blah. We already said this. Now let's go to my favorite part, the electron affinity. What is electron affinity? Well, electron affinity is the energy change when 1 mole of electron is added to 1 mole of a neutral atom in a gaseous state. What's basically saying it's the amount of energy released or absorbed as an electron is lost or removed from an atom. The first electron affinity, or the first time an electron leaves an atom, energy will be released. But then, here's the thing, the more time you try to pull electrons from the atom, we need more energy to remove them. And there will be a lot of pulling force that wants to keep these electrons. Let's just see. Let's give you a real life example. Let's try and see the atom as an abusive stepfather who has adopted a child. Now, the abusive stepfather, he has his real children. He loves his real children. These are the inner electrons. They are inside the inner energy levels. But then there's the stepson, which is the outermost electron, which is farthest away from the neutron, from the nucleus, which is, the center of the atom. Now, he has the ability to pull it back, but it's so much energy to, give it back. So, just lets it go. When he gets some money, he doesn't really want it because he's more happy with his original inner bell. But here's the thing. If one of those people, if one of the electrons that are inside the electrons, the innermost electrons, they try to leave, well, he can't let them leave because they are part of him, and he has a better attraction to them. No, what attraction? Not connection, not enjoyment. He has a better hold on these electrons, so they require more energy and more manpower to remove and separate these electrons. So basically, the first electron energy is exothermic, as energy is released when an electron. Oh wait, I think I messed up. Electron affinity is exothermic process since electrons are attracted by positively charged nucleus. All of their effective energy values are exothermic changes since the effective electron is above the it's endothermic process inside the electron. Oh my god. So basically, it's the opposite of that. I was wrong. When we say I was wrong, I mean I was wrong, and I would really want to apologize for that, to be honest. I was entirely wrong about electron affinity. I thought I was reading something, and we have 1 minute left before this becomes a 10-minute video, and I can't share it. So basically, in conclusion, electron affinity is the energy needed to add an electron to a neutral atom, and electron ionization energy is the amount of energy required to remove an electron from an atom. Now, here's the thing, electron affinity, if we want to add an electron to a neutral atom, that releases energy, but then as we want to add more atoms, it requires more energy because you see electrons are filled up, which creates you can Google. I'm even explaining it to you. Yeah, bye.